Hi, welcome to Roar Math. Today I'm doing a series of videos on exponential models. All right, it says come up with the exponential model for the following tables. For this first one, we'll notice that the input, our x variables, are going up at a steady pace of 1, 0, 1, 2, 3. So what we want to do is we want to figure out our factor, our a, what we're multiplying by to move up the table, because that's what an exponential model is. You, instead of adding to move forward like a linear, we multiply. So 4 times a equals 12. We divide by 4. We find out that a is equal to 3. Now we could continue this. We can say 12a equals 36, divide by 12, find out that a is equal to 3. 36a equals 108, divide by 36, and a is equal to 3. And we do want to check to make sure that it's consistent throughout our whole table, that we have a constant multiplier. Because if we don't, then we have to figure out what type of model we have. If we just figure out one multiplier, then it's not necessarily an exponential model. Okay. Now we need to figure out, our model is the form of f of t equals ca to the t. We have an initial value, we have the factor we just figured out. An exponential means that the variable is in the exponent position. Well, we just figured out a, our multiplier. Now we need to figure out our initial, but our initial is whatever our output is when our input is 0. But thankfully we have an input of 0 right there. So I'm going to keep our function notation. So f of t equals 4 times 3 to the t. Now you may have written y equals 4 times 3 to the t. That's fine. Either is a correct way of writing this model. Okay, so we're going to do the same thing over here. We're going to say 3072a equals 768. And then we're going to divide by 3072. When we do that, we're going to find out that a is equal to 0.25. Now, what we could do is we can say if we're multiplying by 0.25, if you put into your calculator 3072 equals, and then type times 0.25, you'll get 768. And then if you hit equals again, your calculator should automatically, most calculators, do answer times 0.25 and give you the 192. And if you hit answer again, you should automatically get times 0.25 and you should get the 48. So you shouldn't actually have to do all of this work each time. You should be able to use the power of your calculator to generate this table, which is a faster way of figuring out if this is all correct, which is nice. Notice this time our input is going up by 5, not 1. So this time it's going to be a little bit different. But because it is still a steady input, what we're going to do is we're going to say we want our input to go from 5 down to 1. We want it to be, so right now our a is 0.25, but that's a input of 5. And we want it to be 1/5 of that. And because this is an exponential model, everything needs to be altered in the exponent position. So we're going to say a is equal to 0.25 to the 1/5. Now, some classes will actually have you take this out to a decimal position. I'm going to leave it 0.25 to the 1/5. You just need to know the directions that you're following to know if you leave it like this or if you actually type in your calculator 0.25 to the 1/5. It is teacher specific. I have videos out there that go to the decimal. I have videos that leave it as a fraction. I have both types out there. You just need to figure out which you are being asked to do. So this, once again, I am giving you the initial value. So we have y equals, we start at 3072, 0.25 to the x over 5. This could have been t or x. I could have written this as y equals 4, 3 to the x, by the way. Input, output. The important thing here is the x has to be divided by 5 because we want this 0.25 is an input of 5, and this now is representing an input of 1. And that's what we want. We want to make sure our factor is representing an input of 1. And so if we take our x and divide it by 5, it now represents a unit input, a unit input of 1. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.